Welcome to qnawire.
We begin this question by applying Newton's second law in this reference frame. This will be the y-axis and this will be the x-axis. Then we will apply Newton's second law to both blocks in both directions. Let us begin by applying to block number 1. So on the x direction, we have that the net force that acts on that direction is equal to the mass of block number 1 times its acceleration in the x direction. But there is only one force that is acting on block number 1 in that direction, and this is the frictional force number 1, which happens because someone is pushing block number 2, so it tends to move in this direction. Therefore, what happens is that block number 1 tends to move in this direction with respect to block number 2. Both blocks will move to the right, but this block tends to move in a slower fashion. Therefore, it tends to fall behind. In order to avoid that from happening, the frictional force appears and try to bring it with the block number 2. Then, this is why we have two frictional forces. One frictional force is acting from block number 2 onto block number 1, and another frictional force is acting from block number 1 on block number 2, trying to make it not move. So for block number 1, we have the following. Frictional force number 1 is equal to the mass of the block number 1 times its acceleration in the x direction. Then, doing the same for the vertical direction, we got that the net force in the y direction is equal to the mass of block number 1 times its acceleration in that direction. But it's not moving and it's not going to move in the vertical direction, therefore its acceleration is equal to 0. Then there are two forces acting in that axis. And one, which is the normal force that block number 2 exerts on block number 1, and the weight force of block number 1. Then we have N1 minus the weight number 1 being equals to 0, so the normal force number 1 is equals to the weight of block number 1. Now, let us apply Newton's second law to the second block. On the x direction, we have that the net force in that direction is equal to the mass of block number 2 times its acceleration in that direction. There are two forces acting on block number 2 on the horizontal direction. And those forces are this applied force and the frictional force that block number 1 exerts on block number 2, trying to make it not move. Then this results in the following. F, that points to the positive direction, minus the friction number 2, that points to the negative direction, is equal to the mass of block number 2 times its acceleration. Okay. Now, let us apply Newton's second law to block number 2 on the vertical direction. By doing that, the net force in the y direction is given by the mass of that block times its acceleration in that direction. Again, it's not moving and it's not going to move on the y direction, so the acceleration is equal to 0. Then, notice that the net force in the y direction is composed by three forces. Two weights that point downwards, and the normal force that the table exerts on block number 2. Then, N2 minus W1 minus W2 is equals to 0, meaning that the normal number 2 is equals to the sum of the weights. Okay, but what we want to determine? We want to determine what is the maximum possible value for this force F, such that one block isn't slipping on top of the other. And what is the condition for this to happen? If they are not slipping with respect to one another, then they are moving with the same acceleration. So the key condition is this one. It must be true that A1x is equals to A2x. This must be true, and I will call these accelerations A only. Then we have something with this equation and this equation at least. It means that using this condition, equation number 1 can be written as frictional force number 1 is equals to the mass number 1 times the acceleration, and for equation number 2, F minus frictional force number 2 is equal to the mass number 2 times its acceleration. Then, notice that we want to discover what is the maximum possible value for the force. So this means that we should also use the maximum possible value for the frictions. And the friction in this context is the static frictional force. So the frictional force number 1 is equals to the static frictional coefficient times the normal force that acts on block number 1. Similarly, the frictional force number 2 is equal to the static frictional coefficient times, and this is an important detail, the normal force that this block exerts on this block. So this is multiplied by the weight of block number 1, because the weight of block number 1 is the force that this block is exerting on this other block. Then it's given by this equation. But we also know that the normal force number 1 is equals to the weight number 1. Then we conclude that both frictional forces are equal. Therefore, let me write it like this. And both frictional forces I will call FF. Therefore, we can write these equations 1 and 2 as follows. FF is equals to M1 times A. For the second equation, F minus FF is equals to M2 times A. Then we solve both equations 1 and 2 for the acceleration. So A is equals to FF divided by M1, and also A is equals to F minus FF divided by the mass number 2. Then we can equate both sides to get FF divided by M1 is equals to F minus FF divided by M2. Now we can solve this equation for the force F. And this gives the following. Send this term to the other side to get M2 divided by M1 times FF is equals to F minus FF. Now send this term to the other side to get that the force F is equals to M2 divided by M1 times FF plus FF. Finally, factor the frictional force to get frictional force times M2 divided by M1 plus 1 is equals to F. So this is the expression for the force F. Now let me clear the board to calculate what is its maximum value. Okay. So the maximum value of force F happens when the frictional force is also maximum. So F is given by the static frictional coefficient times the normal force number 1 times M2 divided by M1 plus 1. But remember that M1 is equal to the weight number 1. Then F is equal to the static frictional coefficient times M1 times G times M2 divided by M1 plus 1. Remembering that G is approximately 9.8 meters per second squared, we get that F is equals to 0.6 times 5 times 9.8 times 12 divided by 5 plus 1. And this gives a maximum force of approximately 100 newtons. So this is the answer for the first item. Now, to solve the second item, let me do a little change in the drawing and keep the result of the first item here. So 100 newtons. Okay, now instead of acting here, the force F is acting directly on block number 1. Then we have to calculate the maximum force again. For that, we have to use Newton's second law. Let us begin by applying Newton's second law on this block on the horizontal axis, because this will involve the value of the force F. So for block number 1, x direction, the net force in the x direction is equals to the mass of block number 1 times its acceleration. Again, both blocks need to have the same acceleration. If they are not slipping on top of one another, then let me write it like that. I will just put A in here. The net force that acts on block number 1 is composed by two forces now. The frictional force that tries to push this block ahead, Then, because of the action of this force, block number 2 will try to keep this block in place. So instead of what we had before, we now have that the frictional force that acts on block number 1 is pointing to the left. And on the other hand, when block number 1 tries to move to the right, it tries to bring block number 2 with it. So now we have a frictional force acting on block number 2 to the right. Then, again, according to Newton's second law, for block number 1, on the horizontal direction, we have plus F minus frictional force number 1. So F minus frictional force number 1 is equal to the mass of the first block times its acceleration. Then, remember that the maximum possible frictional force is given by the static frictional coefficient times the contact force, which in this case is the normal number 1. It's very easy to see that the normal number 1 is equal to the weight number 1. We have already done that calculation, actually. Then, we can use the result to write F minus mu static times the weight number 1 is equal to the mass number 1 times the acceleration. Then, the acceleration, according to the Newton's second law applied on block number 1, is equal to F minus mu static times m1 times g divided by the mass number 1. Now, doing the same for the other block, we get that the net force acting on it on the x direction is equal to the mass of that block, number 2, times its acceleration, which is also a. Then, notice that the net force that acts on block number 2 is only the frictional force number 2. So, we have the frictional force number 2 being equal to the mass number 2 times the acceleration. Then, notice that the frictional force number 2 must be the maximum one, so it's given by the static frictional coefficient times the contact force between blocks 1 and 2. And that contact force is the weight force of block number 1. And this results in mu static times the mass number 1 times g. So, mu static times the mass number 1 times g is equals to the mass number 2 times the acceleration. Therefore, we have the acceleration being given by mu static times the mass number 1 divided by the mass number 2 times the acceleration of gravity. Then we can equate these two equations to get an equation for the force F. By doing that, we get the following: F divided by the mass number 1 minus mu static times g. I have simplified these masses on the second term, is equals to the static frictional coefficient times g times m1 divided by m2. Then F is equals to mu static times g times m1 divided by m2 plus mu static times g. And this is F by m1. Then we can factor out mu static times g to get F divided by m1 is equals to mu static times g times m1 divided by m2 plus 1, and finally send this term to the other side. So the force is mu static m1 g m1 divided by m2 plus 1. Then we just have to plug in the values that were given by the problem, and these will result in the following: F is equals to 0.6 times 5 times 9.8 times m1 5 divided by 12 plus 1. This gives us a force of approximately 41.6 newtons. So this is the answer for the second item. Then, this is the final answer for the complete problem.